Question 3. These are quite tough, these inverse tan ones, these inverse tan, inverse trig ones here. Remembering that arc sine is the inverse sine, so I've got the inverse sine of x, and if I sine both sides, I've got the sine of y equals x. And what I'm going to do now is differentiate both sides with respect to y. So I'm going to get dx by dy here, and sine, of course, goes to cos. Now, you don't want dx by dy, we want dy by dx. So we've flipped this upside down. So we'll flip this upside down as well and get 1 over cos y. That would be the answer, but this has got a y in it, and we really want it to have an x in it. And so the trick we're going to use here is remembering that sine squared theta plus cos squared theta is equal to 1. And so if I want cos theta all on its own, that is 1 minus sine squared theta all square rooted. So either 1, take away this, and then square rooted to get that. We've not got a theta, we've got a y. And so the cos of y is the square root of 1 minus sine squared theta. Sorry, 1 minus sine squared y. And the reason for doing all of that is that sine squared y, or sine y, is equal to x. So this is 1 over the square root of 1 minus x squared. And the others are done in a similar way. I think I'll do this one here next as well. But again, to get rid of the inverse tan, I'm going to tan both sides. Tan y is equal to x squared. And then I'm going to use my implicit differentiation. So tan goes to sec squared y. Because there's a y there, I need to write dy by dx next to it. And differentiating this makes 2x. So dy by dx is 2x over sec squared y. And using a similar trick to this one down here, but this time using the other rule being that tan squared theta plus 1 is equal to sec squared theta. And so what do I want? I want sec squared y is actually just 1 plus tan squared y. And tan y was x squared. So I've got 1 plus x squared squared, or 1 plus x to the 4. And so this answer here is 2x over 1 plus x to the 4. Similar ideas with this one here and this one here to try and work through to get them back in terms of x's. Some challenging questions.